as we were going to start rigid body dynamics. By the name, it feels like, okay, this is a very big thing. But still, if you understand this, this is the most easiest chapter ever. Rigid body dynamics. The idea itself revolves around rigid body. First, we have to understand what is called as rigid body, and then we have to understand the dynamics of it. So, two parts are there. Rigid body means what is rigid body? Means you can divide this whole chapter in two parts. Why or not? Rigid body and its dynamics. Right or not? So along this rigid body, first we will understand what is the meaning of rigid body, which we call it as introduction. Okay, second part is our ideas, like how this rigid body is considered and how to understand this and how to consider it properly. Are you able to get me or not? And there one property comes which we call it as moment of inertia. And dynamics, as we know, it is like rotational plus translational motion of these bodies we have to study. Are you able to get me or not? So all these combined, we have four parts. Main point is four parts of the whole chapter is there, and we are going to pick up one part and we are going to counter it. Now, main important criteria of this chapter is I will teach with the help of one best thing, which we call it as instantaneous axis of rotation. IAOR, word or not, where I will stress a lot of things, and this part I'm very good at. So I'll teach you this method, which is a kind of a very good thing in physics. Are you able to get me or not? Okay. So as we were going to start, let's start with the introduction. And initially itself, like in introduction part, question is first we'll define what we call it as rigid body. So question is, what is a rigid body? Yes. So first idea is, let's suppose if I am defining a rigid body, okay, what is the meaning of this? Yes. So like let's suppose I took one disk, void or not, a kind of a disk I took, and it's like this, it's arranged like this, void or not. Now you can see that on this disk there are many points, yes or no? I selected some random points. Let's suppose I selected point A and point B. Then a rigid body, the idea of rigid body is, let's suppose if I select these 2 points and initially when the system was at rest, if I measure the gap between them, let's suppose this distance I denote it as d, or let's suppose I denote it as by r, word or not, then this whole body is going to be determined as rigid body when this r never changes. Yeah, any 2 points on a body, word or not. Okay, r never changes, then we call it as a rigid body. Are you able to get me or not? So let us define it. What is a rigid body? A rigid body is a, okay, 1 minute, I'll write. Or you can say it is defined as a system of particles, why don't know, in which the distance between any 2 points, the distance between any 2 points on the body does not change. Are you able to get me or not? And that is called as a rigid body. That distance between any 2 points on the body will never ever change. Are you able to get me or not? Like let's suppose if I take a ring, or not, I have some kind of a ring, So if I select any 2 points on this ring, let's suppose I selected point A, got it or not? Point A1, let's suppose I selected point A2, let's suppose I select point A3. So when I combine this, the distance between A1 and A2, okay, this distance, or between A2 or A3, or between A1 and A3 will never ever change. Are you able to get me or not? So basically we can tell that this means that we can say that the rigid body is a mathematical concept. Yes or no? Is a mathematical concept. This means that it is applicable for any kind of a body. Even if two particles are there which are kept at rest over here, and if the distance does not change, they are rigid body. Are you able to get me or not? So we can say that rigid body is a mathematical concept, and any system which satisfies this condition is called as a rigid body. Are you able to get me or not? Is that clear? So we'll take one example. One more example we'll take. Hold on. Like let's suppose there is a ground, and on that ground I place two blocks. Okay, and between these two blocks I attached one spring. Are you able to get me or not? One minute. I attached one spring over here like this. Are you able to get me or not? And this one was moving with initially v1 velocity, and this one is moving with velocity how much? v2. This is block A, and that is block B. Are you able to get me or not? So idea is very simple. Point is very clear that if velocity of block A, like this is block A, if I say, so if velocity of block A is exactly equal to velocity of block B, then what will happen? This spring will not move here and there, and the distance between A and B will remain same or not? Yes. So then we can say that then this implies A plus B system, not only A or not only B, A plus B system is a rigid body. I will write the short form, which we call it as RB. Are you able to get me or not? Is that clear? Now, second idea is if V1 is not equal to V2, then A plus B system, yeah, I have to tell that a system is not, so not a rigid body, I'll write NRB. Are you able to get me or not? So NRB means, are you able to get me or not? Clear? I'll take one more example. Okay. Okay. Now look over here. My goodness. What has happened? No problem. Okay. Let's delete it. Let's suppose there is a ring. Are you able to get me or not? solid ring will be a great idea, but okay, no problem. Control C, Control V. Now, if I consider, let's suppose if in this ring, I placed two beads. I'm placing two beads. Are you able to get me or not? Like this way. Is that clear? And both of the beads, A and B, rotates with angular velocity how much? Omega. Is that clear or not? Now, ring is fixed. So question arises once again that what is rigid body? Are you able to get me or not? So ring is fixed, but beads A and B are moving on the ring. Are you able to get me or not? So question arises that out of all these, which one, what I'll consider as rigid body and what I'll not consider as a rigid body? Tell me. Yes. Which kind of a system is a rigid body and which kind of a system is not a rigid body? Yes. Yes, you can write anything. See, if I just consider the rings when they are rotating, so their distance gap will always remain same or not. Diameter will always. So that means that we can say that A plus B system is my rigid body. Yes or no? Now, if you just consider A plus B plus ring at that same instant of time, at with respect to every point on the ring, these beads are moving away or not? Yes or no? So A plus B plus ring system is not a rigid body. Are you able to get me or not? Second idea is that if omega 1 or omega of bid A would have been not equal to omega of bid B, then also what will happen? These separations will continuously change or not between the beats? Yes. So that means that at that time A plus B system is also not a, yeah. So yeah, so now you got the idea that what is a rigid body? Yes or no? That distance would always remain same whether they are having velocities or whether they are having whatever it is, the distance would always remain same. Are you able to get me or not? Is that clear or not? And with this approach we'll start our idea of translational motion. Are you able to get me or not? So with this idea, so let us have some points about rigid body and then we'll define perfectly our rigid body. What it says that distance between any two random points never, or distance between any two random points never changes with respect to time. First conclusion is that, yes or no? So then we can create our formula for it, yes or no? Let's suppose if I have a random rigid body, okay, like this way, or wait, like this way. Are you able to get me or not? Or you can consider a perfect symmetrical object. It's your choice. Got it? So what I'll do, let me consider a pure symmetrical object such that I can write the things properly. So let's suppose this is my some kind of a disk. Are you able to get me or not? And let's suppose there are 2 points on it, point A and point B. Are you able to get me? The point A was having velocity like this way, v1, and point B has velocity like this way, v2. Are you able to get me or not? Distance between these 2 points is, let's suppose, RAB. Are you able to get me? So question arises that how you are going to relate them. Now let's suppose with the horizontal line, with this line, okay, they make some angle theta. So let's suppose this angle is how much? Theta 1, and this angle is how much? Theta 2. Is that clear? So then how to define the idea of rigid body? For that, question arises how you are going to say that whether the body is uniform or not. So to say that, yeah, first idea is first we will resolve the velocities, yes. So we know that there will be two components, yes, one along this side, one perpendicular to it, yes. For this also two components, this side and one perpendicular to it. Are you able to get me or not? So this is, yeah, so this is v2 cos theta 2, v2 sin theta 2, yes, v1 cos theta 1 and v1 sin theta 1. Are you able to get me or not? Now idea is if these velocities, like if the distance between AB will not change, so we'll say now that d of RAB with respect to time dt will be equal to 0. First concept of rigid body. Now what is distance of RAB? It's a relative velocity between these two bodies or not, which is v2 cos theta 2 minus v1 cos theta 1. If they are in same direction, that must be equal to 0. So first idea is what? v2 cos theta 2 must be equal to v1 cos theta 1, such as to say that this is a rigid body. So first criteria of rigid body is that the relative velocity along the same direction between the two particles must be same. Are you able to get me or not? Is that clear? So this way we'll now, second idea is, like, as we know that the perpendicular velocities on the radius always creates angular velocity or not, yes. So what was the omega of B with respect to A formula? It is nothing but omega, velocity B perpendicular minus velocity of A perpendicular divided by R AB. Yes or no? Correct. So velocity of B perpendicular is V2 sine theta 2 plus V1, because they are opposite direction, V1 sine theta 1 divided by RAB. That's your answer. Yes or no? So that is the angular velocity equation between any 2 points of a rigid body. Clear or not? Yes. So that means that, can we say something about it? So that means that as you observed with respect to A, if I am an observer, let's suppose if I were an observer and you are sitting at A and you are observing B. So you get omega of B with respect to N, means you will see that B is doing a circular motion over here. Yes or no? You will feel that the B is trying to do a circular motion with the relative velocity how much? Omega. Are you able to get me on? And this only gives us one conclusion, that with respect to one point on the rigid body, the remaining points only perform circular motion. Are you able to get me or not? Is that clear? Right. Then we'll move ahead. Okay. So this is the idea, that if I have a rigid body, every point on it will perform a circular motion, and whatever you will consider, that is the condition of a rigid body. Okay. So next conclusion is, so this gives us one more conclusion. This means that one point on rigid body can only move perpendicular to the line joining another point on rigid body. So see, if I select any kind of a line joining 2 points, so B is only going to rotate in omega. That means it is moving perpendicular to A or not all the time. Are you able to get me or not? So this is only the criteria, that a rigid body, if I consider a rigid body, any point with respect to another point should always move perpendicular. Are you able to get me or not? Is that clear? So we can say that if there are many points on rigid body, like on this, if there would have been point C, point D, each point performs a angular velocity. Yes or no? So we can also say that as each one is moving perpendicular and the distance is also not changing, that is only possible if the omega of point A with respect to B is equal to omega of point C with respect to A is equal to omega of D with respect to A, or whatsoever, means all the points, or you can say that angular velocity of one point with respect to another point okay, like you can say all the other points on rigid body is same. Are you able to get me or not? Now look over here, give the heading, second point, types of motion of rigid body. Got it? So basically we have three types of motion of a rigid body. pure translational motion. Second, pure rotational motion. Yeah. And then last one, combined translational plus rotational motion. This is also known by a name, combined T plus R motion. Why or not? And we are going to talk about all of them in the all time to try to make us understand what is the meaning of it. Go ahead or not. But before we go over there, to talk about these combined translational, combined rotational, or whatsoever, we want to determine something. 1 minute. Uh, yeah, we want to determine something, and we'll look into that, and that is called as kinetic energy of a body. Are you able to get me or not? But let us talk about these ones, and then we'll move ahead. Okay. So what is first? What is this pure translational motion? Tell me something about it. No. Mm-hmm. Think. Okay, let's imagine something. Two ideas I will give. Okay, then we will give a depiction of that. Not this. We'll put a ring over there. So I move this disk. Let's suppose this disk was over here at time t. And this disk at time t plus delta t. There are 3 points, A1, A2, A3. So if I look the translation of A1, A1 is over here. Yes, correct or not? A2 will look like this way. Oh, it will go over there. Sorry. And A3 over here. Yes or no? What is common in all these three? Then what is common over here? Location. So does location means you are saying that after some time the location of the particles are changing? Yes or no? Each particle's location. Okay, what is the displacement in A1? This one. Displacement in A2, this much. Displacement in A3, this much. What is the common between these three red lines? Are they same? Are they of same length or not? Yes. So that is called as translational motion. So what is translational motion? Idea is very clear that, let's suppose if I find the displacement between A1 or displacement between A2 or displacement between A3, what we are going to see is these displacements are exactly same. Yes. So let us define this. What does it says? The displacement of each particle, okay, of system is same during a during any time interval, okay, then we call it as a pure translational motion. Are you able to get me or not? So this means that all the particles have same displacement, comma, velocity and acceleration, then we will call that system as which kind of a system? Pure translatory system. Are you able to get me or not? Another idea is, that means that what is the clear idea of this is, like, let's suppose if a block is moving on a straight horizontal path, okay, let's suppose there is a block. If it moves, as you will see that, let's suppose it has some velocity v. Now you will see that, let's suppose if I select any 2 points on this block, two end points. So on this straight path, whatever is this distance will always remain same or not? Even if I consider a curvical path, let's suppose a path is like this way, and I consider a block over here. Okay. So on this block also, even if I move it like whatever way, like if it is going like this way, it has velocity like this way over here. So when I select any two random points, once again I'll see that between these 2 points, they always, whether it goes all the way from here, there or whatsoever, every point, this distance between AB always remain same. So this is a straight path, yes or no? And this is curvilinear. Let's write perfect name, linear basically, yes or no? So whether I select a linear path or whether I select a curvilinear path, what do I see? The distance between these two particles remain same. So these two ideas of linear motion and curvilinear motion are also called as translatory motion. So what are these are examples of? Because here also the displacement between the particle never changes. Are you able to get me on? So many people think that the curvilinear motion is a rotational motion. No, curvilinear motion is perfectly a translational motion. Why? Because the distance between the particles is not changing. Are you able to get me or not? Is that clear? Confirm. Can I move ahead? Now, Let us give the heading pure rotational motion. Okay. Now let's suppose I have a hinge. I have a hinge like this. Okay. And with this hinge, I attach a disc. Can you get the idea or not? And this disc translate in some time t. Let us make it more. So this hinge has came over here in time t. Are you able to get me or not? So you see that, let's suppose if I select some random points, point 1, okay, point 2 and point 3. What do you observe? Point 1 has traveled over here, part 2 has traveled over here, yes, and particle 3, point 3 has traveled over here or not, yes. What is common in all these particles? What is common in all these points? Path is not same, but you see that, does the angle made with the vertical is same for all of them or not? Then we call it as a pure rotational motion. Of course, we know that the path is not same, so it is not a translative motion. But which motion it is? Yeah. So then, yeah. So let us define rotational motion. What is a rotational motion? So it says that here it says that every point on the body moves in a circle. Moves in what way? Circle and covers equal angles in equal interval of time. So then we call it as rotational motion. Are you able to get me or not? Okay, so we can say that the angular displacement is identical for all points. Are you able to get me or not? But all of these have a important criteria that they must be, okay, this rotation means this only is possible if I take the rotation must be done for a fixed axis. Are you able to get me or not? So here we'll conclude that not only theta. So we'll write that first is theta 1 is theta 2 is equal to theta 3. Second one is omega 1 is equal to omega 2 is equal to omega 3. And third one, alpha 1 is equal to alpha 2 is equal to alpha 3. Here what was happening? S1 was equal to S2 is equal to S3. Velocity of 1 is exactly equal to velocity of 2 is equal to velocity of 3. Means if this is going with velocity v, this one will also go with velocity v. If this is v, and this is also v. Are you able to get me or not? Yes. Acceleration of 1 is equal to acceleration of 2 is equal to acceleration of 3. You can also take one more example. Let's suppose if I have a rod. Let me delete it. Let me take a different color. As I told you, I'll make you understand rotational in a perfect way. Let's suppose there is a rod. Now, on this rod, what I'm doing is, once again, I'm doing same thing. That now, I have fixed one of its point and I'm rotating with angular velocity how much? Omega. So if I select 2 points, point A and point B, what I will see? The distance remains same, and according to circular motion, this moves with same omega, or say according to rigid body concept, this would move with same omega. Are you able to get me or not? So what I observe, are they doing any kind of translation? No, their distance always remains same, but you look over here, the velocities are different at each and every point or not? Yes. So here velocity of A is not equal to velocity of B. But what is same? Omega of A is equal to omega of B. So that is why we call this as rotational motion, because the necessary condition of translational motion is that each point should have a same velocity. And this is only possible, velocities of each point will not be same. It is only possible if the particle rotates in a circular motion. Other than that, it is always same. You can see that over curvilinear also it is same. Are you able to get me or not? So necessary condition of rotational motion is pure circular path. First point, and second point is a fixed axis of rotation. Are you able to get me or not? Okay. So this is called as pure rotational motion and pure translational. Yeah. Now, what is the idea of this combined translational plus rotational motion? Tell me. Give me one example. Try to make me understand. What will happen actually? Try to make me understand. Think. Let us see one thing. Let's suppose if I have a wheel. Okay. Yes. Let us understand this. Okay. Now see, let's suppose there was a ball which was moving also forward, and if this ball is rotating also. Okay. So let's suppose this has velocity v and this has angular velocity how much? Omega. Then such kind of a motion is called as combined translational plus rotational motion. Because you see over here what will happen, as we can see that, see every point over here, select any random point. We draw with black because this red is quite shiny on blue surface, yes or no? I select some random points, and according to rigid body concept we know that every point should move with same velocity, yes. So all of them are moving with same velocity, yes. And if it is omega, so we know that every point is rotating with similar angular velocity omega. So then if I combine it, so we can say that whole thing moves with same angular velocity omega. Are you able to get me or not? So every any point if I select, this is also rotating, this is also rotating, and they have similar angular velocities, yes or no? So when I combine, then every point has velocity v and it is rotating, then we call it as combined translational plus rotational motion. Quite or not? Similarly, over here, velocity v rotating with omega. Then we call it as, so this is what? Translation, yes? And this is, and in combined way, this is called as combined t plus. Are you able to get me or not? So we can say that the particle or the body have both angular velocity and forward velocity or backward velocity. Yes or are you able to get me? So question arises, let us give it a proper form. Let us give it as a proper theoretical idea. So let us write this. What does it say actually? It says that all the points, okay, on the body rotate about an axis of rotation. Okay, and we call it as AOR. Learn these names. These names are going to be very, very useful. So first name I give AOR. First, see, I'm naming some things T plus R. Then I'm using some words RB, NRB. Yes or no? So this name I have given this time ARB. Okay. AOR. Axis of rotation. Now, see, the idea is it says that all the points on the body rotate about an axis of rotation, and this axis of rotation actually moves relative to the ground. Relative to the ground, and such kind of general motions are called as combined translational plus rotational motion. Are you able to get me or not? So these kind of are an example of combined translational and rotational motion. Like we can take an example. Look over here. Like here, this is my axis or not? This is my axis of rotation or not? So all the particles are rotating with respect to axis of rotation. Yes or no? But that axis of rotation with respect to ground is moving like this way or not? Yes. So see, the axis is here, axis is rotating also, and with respect to ground, axis is moving also. So this is why this axis of rotation is performing two things, rotating plus translating, and then we call it as combined translational plus rotational motion. Are you able to get me or not? We can take one more example, like let's suppose let us delete it. Control C, Control V. Got it? My goodness, what is happening? Okay, let us do one thing. Like let us copy this. Control C. Why this whole system is not coming over here? Okay, so let us take an example. Let's suppose if I have a trolley. Yeah, and it's moving in a space. Got it or not? Okay, so I just move this trolley. Is that clear? Now, this is at time t. Sorry. And this is at time t plus delta t. Are you able to get me or not? Are you able to get me? So two times I'm considering t and t plus delta t. Now, let's suppose if I have a disk which was fixed over here with a hinge. Word or not? So let's suppose it is fixed over here with a hinge kind of thing. Word or not? And as we can see over here, see, if I select this once again, these 3 points, 1, 2, and 3, what you will observe over here, when this hinge, when it starts to move, suppose it has, yeah, yeah. So if it starts to move, what you will feel? Where this should go, forward or backwards? Hinge should go where? Forward or backwards? And that's an interesting question. No, no, no. Is there a pseudo force if it moves with constant velocity? Hmm. So it does not. So it moves forward. Are you able to get me or not? So, and you will see that. So you see that this hinge is my axis of rotation or not? Yes. So see, according to the AOR, the particles are doing some kind of translation or not. See that these particles will come over here. Yes, one, okay, two, three. Earlier they were on this line. Yes. Now they have moved. Yes or no? So with respect to the vertical, they are always translating like this way. So this is why. And another thing is, you see that this axis of rotation is also moving with respect to ground. Yes or no? With velocity v. So what is happening with respect to axis of rotation? Two things are happening. With respect to AOR, first translational is rotation is happening, and then translation is happening. So this is why this is called as combined translational plus rotational motion. Are you able to get me or not? Is that clear? Okay, so let us do one question. Example. Okay. There is a hinge. Okay. And with it, I attach a disc. And this disc is given some velocity along this direction. Are you able to get me or not? So tell me, if I give this velocity v, then case 1, when I consider a case 1, okay, which just includes, case 1 just includes, let's suppose, uh, case 1 is if the disk is welded or fixed, or you can say nailed to the rod, word or not, then talk about the system, whether it is rigid or non-rigid, and then talk about its motion. Case 2, word or not. We'll write it here a little bit more down. Case 2, okay, this is my hinge, and in case 2, what is happening? If the disc, okay, is hinged to the rod, got it or not? Or you can say, or free to rotate, or free to rotate about end of the rod. then rod plus disc, which kind of system it is and which kind of motion it is. Try to do it. I'll just bring some water, okay? Tell me, what is the situation over here? Yeah, first case is nothing is moving. Means it is welded. Of course, it will move. Means you have to think. This is just the given. See, if I consider the first situation, then what will happen? This, what it is saying, the disc is welded or fixed on the or nailed to the rod. Means it is perfectly fixed on the rod. Are you able to get me or not? So how it? Let's suppose if it is a if this is a hinge and if this is my rod, got it? And if this is my disc, yeah. First case is not hinge is not moving. First case is disc is not rotating or doing anything. Are you able to get me or not? In second case, disc is free to rotate. Then you have to tell what is actually happening. Both are hinge. What will happen? Okay, see, if I push it, then this one will move will like this way or not? Disc will go. Disc will have velocity like this way. Yes, yes. And if I consider the second situation, disk is rotating. Means if this velocity is provided, what will happen? It will still move like this way. Yes or no? Hello, Nikhil, Nitin. Good evening. So this is velocity v. This is also velocity v. So what is actually happening in both situations? So we can say now that this motion is like this way. Yes or no? So we'll say that as this system is there and it is fixed, so no change in the distance is happening. So we'll say that this whole thing is a rigid body, and disc plus rod, both of them are going to just rotate only. Yes or no? So both are going to do pure translational motion. Now here, as this disk is uh, free to rotate, means this disk can rotate by itself over here. Are you able to get me or not? Means you pushed it and then hinge is rotating and this is also spinning like zzz over here. Are you able to get me? So then this is what is actually happening. So rod, don't say like that. Rod does pure rotation because rod will rotate like this way. Okay, Nikhil. Good night, Nikhil. So rod does which rotation? Pure rotation. Are you able to get me or not? But this over here just does pure translation because it will not rotate on. It will just slip as the rod will go up. It will slip a little bit, slip a little bit, slip a little bit. Are you able to get me or not? So this is why this is neither a pure rotation or I mean, this is not a combined motion. You can say like that. Are you able to get me or not? Yes. So that means that it means over here as the distance does not remain same. This is not a rigid body. You can say because distances does not remain same. Are you able to get me or not? Is that clear? Can you understand all these points or not? Let us talk about another example. Okay. Uh, 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 but this one will be okay. So what my plan is that today we completed till rotational over here. Yes.